All right, everybody, welcome back to the channel and welcome to today's video. In today's video, I wanted to go over the differences in calibrating filament in Bambu Studio as well as in Orca Slicer and go through all the tips and tricks on how to calibrate filament in each. Our friends over at Aceaddity sent me a roll of their Tricolor PLA silk filament to try out, so I thought this would be the perfect opportunity to take some brand new filament, review it, and also go through the calibration steps. We'll take a look at Bambu Studio. We'll also take a look at Orca Slicer to see what the differences are and why you may want to use one over the other. At the end of each, we'll print out one of the cool benchies that the channel is known for, and we'll see if there's a discernible difference between the two. So this isn't Bambu filament or anything like that, and it's one that I've never printed with before, so I don't have anything set up on my printer or in any of the slicers on any Tricolor PLA silk filament, especially the Aceaddity. So today we'll go over tuning in Bambu Studio as well as in Orca Slicer and see if there's a difference between them. So if all that sounds good, then sit back and relax and I'll get everything ready. All right, so here we are on Aceaddity's website, and this is the specific filament that they sent me, the gold, silver, copper, but they do have quite a few of them here from blue, red, and green, gold, green, and fuchsia, gold, copper, and black. That one might look really cool. Blue, green, and orange. That one looks pretty cool, as well as blue, yellow, and purple. So go check it out and see if you like any of these tricolor, but they also have some dual color ones and some other filaments as well. But today we'll be checking out this one. So let's get it loaded into the AMS, and we'll set the color for gold in the printer, and then I'll meet you in Bambu Studio. All right, so here we are in Bambu Studio. So let's go ahead and resync this. And we'll see that our generic PLA silk is listed here. So let's go ahead and start the calibration. So we'll just hit the calibration here. The first one that we'll do is flow dynamics. Okay, so let's go ahead and do the auto calibration. We're going to use the 0.4 millimeter nozzle, and we are going to use the cool plate because, as you know, you can't use the textured PEI plate. You can only use the cool plate, engineering plate, or smooth PEI plate. So that would be right away one of the differences between Studio and Orca, and maybe one of the reasons why you would pick Studio or pick Orca Slicer over Studio. So we will select our cool plate. The only one that we need to do is our generic PLA silk here. And we'll go ahead and hit the calibrate button. And then once it gets done, I'll meet you back here. All right, so we're done with the flow dynamics calibration. So let's hit the next button here. And it's showing a factor K of 0.038 for this. So what we will call this is ACE PLA Silk Studio Auto. So the Ace PLA Silk calibrated in studio with the auto calibration, and that's at 0.038 there. So we'll go ahead and hit the finish button on that. And this has been sent to the printer. So remember that this value gets sent to the printer itself. All right, so one of the other things that we can look at is manual calibration. So I always hit auto calibration in here, and that takes advantage of the LiDAR, and that's where it gets the K value. So it printed out that weird little shape, and then use the LiDAR to determine what the best settings were. But you can also manual calibrate if you don't like that. And what you'll do is, set everything up the same, 0.4 cool plate. You can use the textured plate. So if you do want to calibrate on the textured plate, you can do that. But we'll stick to the cool plate for this one. And there's two different methods here, the line method and a pattern method. So within the wiki here, we can see it go through the flow dynamics calibration as well as the line method, right? In this method, you pick the best line that it's supposed to be, and that'll be your factor K value or whatever. But it also has a pattern, and it doesn't say anything about the pattern here. And I've never done the pattern before here, so let's select the pattern and let's see what that does. So we'll go ahead and hit calibrate on there. And we'll see that it has this cool little chevron looking thing here. So I'll see you when it gets done, and we'll see which one of these looks the best. All right, so here is the pattern that it prints out. And I guess you're supposed to look at which corner looks the best there. So we know that the LiDAR said it was in this area right here. And honestly, if you look at this, you see a little bulge, little bulge, little bulge, right? But you can see that right around in here, this corner to this corner, and then it starts to spread out. So it is right around, that 0.4 area right there. And this got me thinking about this pattern here. I've never printed this one before or seen this one before. And probably the line method, if you wanted to do the manual here, the line method would be good. The only issue with that is I've never had any luck with the line method on the PEI plate. It always kind of messes up and I don't get a great result. So this might be really good to print on the PEI plate to do the manual test on that. So let's go ahead and put the PEI plate in and run this test on there and see if it looks the same or any different. So let's get that set up. All right, so here we are back in Bambu Studio. So we'll go ahead and hit next on there. And again, we can add all of the different settings in there. I'm not going to change anything on this one because I didn't feel like that was a better test than the automatic test. So we'll go ahead and just hit finish on that. Yeah, please input a value. I don't want to input a value, so we'll just cancel that. But let's go back to manual calibration and select the textured plate and do the pattern on that. Like I said, the line, I've never really had much success with the PEI plate. So let's try the pattern on that and hit calibrate, and I'll see you when it gets done. All right, and here we are on the PEI plate, and wow, this did work on the PEI plate. And you can see that, nothing peeled up except for this little tiny piece up there, but that's not very relevant or anything like that. But you can see, if you look at the transition on the corner here, and especially since this is multicolored, you can see these lines through it. And, where it starts to really come together, which I think is right around in here, one of these between the 0.3 and the 0.3, you know, in the middle of the 0.3 there. So if you look at the lines, that looks the straightest, but I think this one looks the best on that. And then you can see that they're not as aligned anymore. So let's go with the value of 0.035 on there. So right in between the 3 and the 4. And on the automatic with the normal plate, it was 0.038. So we're right in that same range there. So 0.035 is the value that we'll go with. So let's go ahead and input that one in there. So we'll just hit the next button. And like I said, 0.035 as the K value. And again, we'll name this Ace PLA Silk Manual for the calibration. And that has been saved to the printer. So that will work for the PEI plate. And I didn't remember to put the PEI plate on that one. That's not that bad though. We can hit manage results and then go right back into here and hit edit, and we'll see that our 0.035 is still there, and then we'll call this one manual PEI for the PEI plate. Save. And if you're ever wondering how to go back in and change any of these are all of the ones that you've done, and you can go back in and change them. All right, so now that we're finished with the flow dynamics calibration, let's do the same thing with the flow rate. So with the flow rate, we will go ahead and hit the auto calibration first. We'll be using the 0.4 millimeter plate. We can use the textured plate and the cool plate on here. So we'll start with the cool plate and then we'll do the textured plate. So let's go ahead and hit calibrate. I'll see you when it gets done. All right, so let's take a look at what it printed, and I gotta tell you, the copper, gold, and silver looks really, really cool. So let's go ahead and hit next on the calibration here. And this is the 4th time that I've tried this and the 4th time that this has happened. And it said part of the calibration failed. You may clean the plate and retry. The failed test result would be dropped. And I'm guessing that the LiDAR is having an issue with the different colors that the filament is. So that's an interesting point and something that I didn't realize until doing this. But if you're doing those multicolor filaments, be aware that this auto calibration, I wasn't able to get this going. And I even changed, I was cleaning the other cool plate and I accidentally scratched the sticker on it. So that's even a brand new sticker on there. So I don't know how much more clean it could be on the plate with the brand new cool plate sticker on there. So this is actually the 2nd time it failed with the new sticker on there. So not able to do that. So we'll go ahead and finish this. It says the result will be dropped. So we will need to do manual calibration. And this calibration is one of the same calibrations that is in Orca Slicer. So we'll do it here and we'll move the results over to Orca Slicer as well. So let's take a look at the wiki on this one. So we'll skip past the auto because that failed 4 times. And I've done this calibration before, but this is a 2-step calibration where it prints these little tabs. And we'll take a picture of this and then zoom in to determine which one of these has the best appearance on it. And that is one of the tricks with this, and I'll say it again during the Orca Slicer piece of this video. But the trick, whenever you're looking at these and having to determine which one is the best, take a picture of it so you can zoom in and out on these. And I'll show you that here in a minute. But this is in steps of 5. And then the next test is in steps of 1 to fine tune it the rest of the way. So we'll go through that, but it would be the same. This is the same test that's in Orca Slicer as well. And for the pattern test in the other calibration, it started at steps of 5. And if you remember, we determined it was 0.035. Well, we could have run that test again and done it in steps of 1, which would be similar to this calibration as well. So if you want to do that pattern test, you can change the steps to steps of 1 after you've done the steps of 5, and then you can fine tune it that way as well if you don't want to use the line test. All right, so let's go ahead and get this going. 0.4 cool plate, and we will calibrate. All right, and I'll see you when it gets done. All right, this is the first test, and this is why I say take a picture, put it on your computer, because you can really zoom in on all of these and determine which one looks the best or the smoothest, right? And the top row, pretty easy to eliminate. Bottom row, pretty easy to eliminate. This one, pretty easy to eliminate. These two are pretty close to each other. And when you have two of them close to each other, pick the higher number here. All right, so we're going to go with 5. So let's go ahead and hit the next button and then fill in the value from the block with the smoothest top surface. So this is cool that we don't have to do all the crazy math that I think we'll have to do in Orca Slicer, but we'll take a look here in a minute. So 5, this is the one that looked the best. And then now we'll need to clear off the plate and then hit calibrate again. So let's hit calibrate. The plate is already cleaned off, and I'll see you when it gets done. All right, so here we are with the finished results. And this is why I really like taking a picture again. It's very easy to see some of these imperfections here. You know, all of them have this little dot in the corner. So now I'm just looking at the crosshatch pattern and which one is the best. And I did take a couple of pictures of it and, you know, got the best picture out of all of them. But to me, this -4 looks the best. So that's what we'll go with on this test is -4. So now we'll hit next here and we'll go to -4. And you'll see that it's changing this flow ratio right here. And now save to filament presets. So what we'll do with this is we'll call this Ace PLA Silk Studio Manual Flow Calibrated. All right, so we know what this is referring to. So this is the manual flow rate calibrated, and we have the flow dynamics calibrated now. The name cannot exceed 40 characters. That's pretty awesome. So I didn't know that either. So we'll just call it Cal. Okay, that's been saved to the preset. So what we'll do is we'll go to prepare. We'll go in here and we'll see that that same flow ratio has been saved in here. And we'll see that that is the name of this filament now. All right, so now let's get a benchy loaded and let's see what our calibration did. All right, now that we have our benchy loaded, let's go ahead and slice the plate. Let's see, 1 hour and 28 minutes, and we'll go ahead and hit print, and I'll see you when it gets done. And again, we don't need to do flow dynamics calibration because we've already done that. All right, so let's take a look at it. And I gotta say, this is the coolest filament I've ever printed with. The gold looks really cool. The silver looks really cool. But the copper is awesome. So this looked really cool. You'll see there's no stringing in the gaps or anything like that. There's no stringing in the front up here. but it just looks really cool, that copper to silver to gold. All right, so here we are in Orca Slicer, and as you can see, the generic PLA silk is loaded in there. So let's go ahead and start with the first calibration, which is the temperature calibration. We'll leave everything as is on there, and we'll see the little tower that it creates, and we'll go ahead and hit slice plate. See, it takes a little over an hour to print it. We'll go ahead and print it out, and I'll see you when it gets done. All right, so here we are with the finished print. And as you can see, it goes over each of the temperatures and the range. And you want to look at this little cone, you want to look at the circle, the overhangs, all of this stuff. And again, you know, taking a really good picture and zooming in and out, you know, will highlight some of those deficiencies. But you should get a pretty good idea of overall which one is the best one. And for me, the 220 temperature that is normally it overall looks the best. Now there's a little bit of stringing here. When you get into the lower temperatures, you get some of the ringing there, and you can see in there. But overall, looking at all of these overhangs and everything, the only flaw that I see is right here, where other ones have kind of multiple flaws in there. So we'll go ahead and set that at 220. All right, so here we are back in the slicer. So let's go ahead and make sure this is at 220, which it already is. And we can go ahead and save this as the Ace PLA Silk Orca calibration. All right. And we'll save that, and we'll move on to the next calibration. And in between calibrations, it is good to go ahead and go up here to File and hit New Project. And then I always hit No to saving changes and everything, and that discards all of the setup that it was doing for the calibration, and it is recommended to do that. So let's move to the next calibration. All right, so the next calibration will be the flow rate calibration, and this is pass 1 and 2. So this is the calibration that we did in Studio, that we're just going to move the results from that over here because it is the same test that we're doing. And the one that this affects is in here, and it is the flow ratio. So if you remember, that was the manual way to do the flow ratio. So let's go back into Bambu Studio and grab the flow ratio number from the Aceaddity filament. All right, so here we are back in Bambu Studio, and we can just go into the filament here, and we'll see that it's 0.9878 is the flow ratio that it came up with, or that we came up with on the last test. Okay, so let's go back into Orca Slicer and put that in. All right, so here we are back in Orca Slicer, so 0.9878. And we'll go ahead and save that. And put it in there. Now let's go to the wiki to show what it's like in Orca Slicer versus Bambu Studio. All right, so here we are in the flow rate calibration, and it's showing each of the different tabs like we did in the other one. So the difference here is you actually do need to do the math here. And basically what this does is in that first test, you take your old value, which is normally 0.98, run it through this formula, right? Old flow ratio multiplied by 100 plus the modifier over 100. which is a bit of a chore to do, right? So we had 5 on there, and I believe, yeah, so this is exactly what we ran into. So with the 5 of the multiplier, our first setting was 1.029, and then in pass 2 we selected -4, and you do the same thing. You run it through the same formula there. So I will say that is much easier in Bambu Studio, because all you do, even though you do the manual, you just select which one was better and it does all of the math for you. So if you're afraid of the math, you can still do that same calibration in Bambu Studio. You'll get the same result, but all you do is select the number that you thought was best on there. Okay. So now let's move on to the next calibration, and that'll be the pressure advance. And in here we have the tower method, the line method, and the pattern method that we showed before. But on this one, we'll do the line method, and we'll see what results that we get from there. Again, on the pattern method here, it's a step of 0.005, where we're going through 0.002 steps in here. So a little bit more accurate. So we'll do the line on this one. So go ahead and hit OK. And we'll see that it shows pressure advance test here. We'll slice the plate. We'll see all the lines and everything. Takes about 15 minutes. So I'll go ahead and hit print, and I'll see you when it gets done. All right, so here we are on the pressure advance test, and the way that you look at this one is you kind of look at the ringing on each side right here. The left side's kind of hard to see here, but you can see a little bit of it. This one's a little bit easier to see. And really, it's this 0.024, which looks like the best line on both sides. You can see it starts to ring again. So 0.024 is what we'll go with. So let's go enter that into our filament. All right, so here we are done with the test. So we'll go ahead and go over here, and we'll enable pressure advance. And it was 0.024, which we found to be the best one. We'll go ahead and hit the save button on there. And this is a difference. So the first calibration that we did in Bambu Studio was basically the same, doing, has the same outcome as this one, right? We're doing the same thing. It sends that one to the printer, which is kind of wonky. This one allows you to do pressure advance. So we'll jump into Bambu Studio, and I'll show you the difference right here, that there's no pressure advance. So here we are in the same filament, and you'll see that it just goes from flow ratio down to the density. And there's no enable pressure advance or pressure advance in Bambu Studio. So the next calibration is going to be the retraction test, and I don't think I've done this one before. So this will be a first time for that one. And we'll start the retraction length. We'll just leave everything set up the way it is and hit OK. And then it has these 2 little towers here. So let's slice the plate. And then before we print it, let's go back to prepare, and let's go to the tutorial, and let's read about the retraction test. All right, so here we are in the tutorial on the retraction test, and this test generates a retraction tower automatically. The retraction tower is a vertical structure with multiple notches, each printed at a different retraction length. After the print is complete, we can examine each section of the tower to determine the optimal retraction length for the filament. The optimal retraction length is the shortest one that produces the cleanest tower. So we'll keep that in mind whenever this prints and we take a look at it. All right, so now that we have it prepared, looks like it's going to take about 15 minutes. So I'll go ahead and print the plate, and I'll see you when it gets done. All right, so here's the result of the retraction test. And as you can see, as the retraction length gets longer, it does start to string up here. But from 0 to You know, it goes from 0 to 2 millimeters here of retraction, you know, all the way up until 1.5 is pretty good. So I don't see any reason to change any of the settings there. If you did have, you know, a clear result where it was, you know, really down here and everything else string really, really bad, then there is a place where you change that. So here in the slicer, you're going to go into your filament and you're going to go into setting overrides. And it's the length of this retraction right here is what you're testing there. And like I said, 0.5 looks to be correct. Because again, if you go into the calibration for this, 2 millimeters, 0 to 2, and each step is 0.1 millimeters. So we saw on ours that it was great all the way up until about right there, probably like 1.5. So anything in there looked to be fine. There wasn't a discernible difference between there. But if you did see a difference there, then again, you go in here, setting overrides, and change your retraction length. All right, so let's get into the last test that we'll do today. So we'll go ahead and hit new project and clear everything out. And we will go to calibration. We won't do the tolerance test, but we will do max flow rate. And the max flow rate test helps us to determine how fast we can print the filament at. So it has a starting speed and an ending speed, and it steps up by 0.5 millimeters at a time, and we'll need to look for ringing in the object that it prints. I have done this test before, and you'll see that it goes around these curves and everything, and we'll be able to see some of the stuff in there. I'll take a good picture of it. But what this changes is the max volumetric speed, and right now it's set at a crazy number, but we'll see after the test and everything that this is set to probably a really low number, where most of the Bambu filaments are in like the 20s, I believe. Oh, we'll mess up the test if I change any of that. So let's go ahead and get this sliced. And in here, if you select speed right here, you can see the different speeds at which this is going as it prints this deal. So that's kind of a cool little thing. So I'll go ahead and get this printed out. Let's see what it looks like. It's going to take about 45 minutes. So I'll get this printed out and I'll see you when it gets done. All right, here we are on the test for the max flow rate, and we don't see any separations or anything like that through all the speeds that it went through. You can see that on all sides. So that means that all the speeds that it tried, it was able to do, and there wasn't anything that caused any separation or anything like that. So now that we're back in the slicer, what we'll want to do is hit new project and discard all of that stuff. And then we can go into the filament here, and we'll see that the max volumetric speed at normal is 7.5 millimeters cubed per second. And we'll see for other, just normal Bambu basic is all the way to 21, and this was able to go all the way up on the test. So one number that I like to use that I think is comfortable to use here is 15. It's not quite the 20 and all of that, but it's definitely a lot faster than it was before. So we'll change it to that, and we'll go ahead and save that. And then let's get a benchy loaded and let's see what it looks like. All right, here's the benchy loaded in here, and we'll go ahead and slice the plate. Change this back to line type. We'll see an hour and 8 minutes. And if we were to change this back to the 7.5, you will see that it does change the print overall. So when we slice the plate, you'll see that it added almost 15 minutes in a 1 hour print, which is pretty significant. So we'll go back here, and if I just hit the redo button right there, it'll turn it back to the 15 that I had it saved on. Let's go ahead and slice it on that, and let's go ahead and print it out and see what it looks like. I'll see you when it gets done. All right, so here's the finished result from the Orca slicer. And as you can see, the silver, the gold, and the copper. No stringing, no gaps. Looks really, really cool. This is really, really cool filament. I really, really recommend this filament. And I hope you learned a lot from this video today. And as you can see, when I put them side by side, can you really tell the difference? Now, I switched these around for you. You leave in the comments and you tell me which one this one was calibrated with and which one this one was calibrated with, and tell me if you can tell a difference. So I hope you learned something today, and I hope we all had some fun watching me go through both the studio as well as the Orca slicer calibration steps to get to these perfect benchies. And there's not a flaw on these benchies, really. They are 99.9%. So again, leave your comment down here and let me know which one of these is on the right, which one is on the left. And I hope everybody enjoyed today's video. Be sure to smash that like button. Be sure to subscribe, and don't miss next week's video. I have a really cool video planned for next week, so don't miss it. Be sure to hit that subscribe button. See everybody next week. Thank you, everybody. Thank you.